How you doing, guys? Bioinformatics guy here with another video of the series Bash Essentials for Bioinformatics. In this video we will be taking a look at a really cool tool in command line which is known as Grep. So Grep stands for Global Regular Expression Print. You don't have to remember this name, but let's see how we can use this in command line. So let's get started. So before we start, let's create a small practice file. If you don't feel like typing whatever I'm gonna type, you can copy this from over here from my website. As you can see, this ls command is showing everything, so we are in the right directory. And now we have to paste this to create this practice file. So the next line that I want in this file is this line contains the word practice, no, pattern. And then we will add this double caret sign so that the line is dependent. So we can also try to head on this practice.txt file to see if it's working fine. Yeah, so it's working fine. The next line I want is that another line here. And then I want pattern appears in lowercase. Okay, then I want another line. You can also find this online. And then we will have the final line. Final line without the word. Let's head on our file and see if we got everything. So we have this first line which says this is line 1. Then we have this line contains the word pattern. Then we have another line here. Pattern appears in lowercase. You can also find this line online. And final line without the word. So our practice file is ready. And now we can start with our tool Grep. So the thing is that this tool Grep is named as Grep. So you can simply write this, and then comes the pattern, and after the pattern comes the file name. Alright, so as you can see that this is the basic way to work on this and to use this tool. So this is an example. If we hit enter, we will get an error, of course, because this is not the real thing. So let's try this on the file that we just created. So we want to take a look at the pattern line, and our file is practice.txt. So if I hit enter, you see that this has highlighted the line word in it, and it's highlighted in red. And you can see each line which has this word line in it is printed out. And if it was a bigger file, then only all the lines which have this word line will be printed out. So what we can try is that we can try to look for another pattern which is gonna be pattern. So if I hit enter, we see the pattern in only lowercase, but you can see in our file we have this pattern in uppercase as well. But if we want to ignore the case sensitivity, we can use this flag -i. So if I add -i over here, now I should be able to see all the occurrences of pattern in my file. So you can see that this line contains the word pattern, and pattern appears in lowercase. So now we got the uppercase as well. And if you want to search for the whole word, like you see that when we search for this thing, line, if it was present in this word, inside this word, we were also seeing it. But what if you just want to see the whole word and not the semi matching of it? So what you can do, so let's clear up some space, and then I'm gonna tell you another flag, which is -w. So we are gonna search line, and then we are gonna add -w over here. So if I've added this W, now you can see that the line with the word online is not appearing. So now it is only looking for exact matches of the complete word. And what if you are talking to a friend and you are sharing your screen, and then you want to explain the other person which line or which specific thing you are talking about? So in that case, you need the line numbers. So in order to add the line numbers, you can simply add -n. And if I hit enter, you are able to see the line number 1, 2, 3, 5, 6. And you can see that it skipped number 4 because that line is there in the file, but it is not there in the results, as that line does not contain the word line. So you can also invert your search. So if you want to see all the lines which do not have this word, then you can use this flag -v. So if I hit enter, now we just got that line pattern appears in lowercase. Let me do one thing cool over here. So if I add the other flag -n, now the line number for this is gonna be 4, because this is the same line which was skipped in my initial search. All right, so we can kind of confirm this by doing this reverse search. Okay, so sometimes when you are looking up in the file and you get your result, just looking at the same line does not help that much. So we have another flag which is known as -a. So -a will let you look around. So -a also needs a number to know that how many lines you want to look. So if I will hit enter, wait, we have to change the search. Yeah, it works better with this because now we are taking a look at this whole thing. And if I hit enter, you see that there was only one line which contained this word pattern. And since we have added this one with this -a flag, we are also able to see another line, the line which is below it. So that this -a flags give you a little bit of context. So I guess we know a little bit of tricks, and now we are able to work on a real example. So let's clear up some space. Okay, and then we are gonna be working with this file known as sequences.fasta. So let's take a look at the complete file and see what's inside this. So this is basically a small file. It does not have thousands and millions of sequences. So you can just take a quick look at this file, and then we will start using grep on this. So first of all, let's say that we want to see only the hypothetical sequences. So we will write grep, then we will write our pattern hypothethical, and then we will give the name of the file. So if I hit enter, I'm only seeing the lines which contain the word hypothetical. And if I also want to see the sequences, what can I do? Because right now you can see that I'm only able to see the headers of the headers of the genes, and I'm unable to see the sequences. If I want to see the headers, then remember we can use our a tag -a, and I'm adding this one, so this will also give us the context wherever that line is available in the file. So if I hit enter, you see that this is giving me this header of the FASTA gene, and then we are also getting the sequence, and then these are the separators which tells us that this was one entry, and then we have the other entry. So let's clear up this space, and then I'm gonna tell you one cool thing that you can do. So if you want to extract all the lines which start with something specific, as you have seen in our sequence file, that all the genes are starting with this greater than sign. So if you want to grab it a bit differently, like grabbing all the lines which are starting with this greater than sign, then you can use grep, and in the inverted commas we will use this symbol. This symbol is for when you want to take a look at only the starting of the lines, and then comes the pattern. So the starting of the line should look like this, and then we will give it the name of the file, which is sequences.fasta. If I hit enter, I should be able to get all the headers of that file. You see, I am getting all the headers, and it has already highlighted this thing in red, which is being matched. And moving on, if you want to count, you can do it with this other flag -c, which stands for count. And if I hit enter, I am getting 8 because we have 8 sequences. What if you want to exclude some of the genes? Let's say that we do not want the hypothetical and we want only the real genes. So what we can do is we can look for all the sequences, then we can use our very own pipes that we learned yesterday, and then we can apply another command, which is gonna be grep, and then we are gonna use the -v flag to invert our search, and then we will type hypothetical. Alright, and if I hit enter, I should be able to see the header of all the sequences which are not hypothetical. So if I hit enter, you see we got our desired result. And what if you want to get the sequences with specific patterns? So we will write grep, then we will write our sequence that we want. Let's say we are interested in GCTA, and then we will give the name of the file, and now we are able to fetch the sequences which have our specific desired sequence. What if you want to see the headers? So just like we used -a, -a stands for after. We can use -b, which will stand for before. So now it will give you one line before our search. So now we are able to see the gene names, and then we are able to see the sequence as well. And now let's try to combine different flags. But before that, I would like to clear up some space to make it easier. Let's say that we want to grep, and then we want the line numbers. Also, we want after, like one line, and we want to take a look at all the sequences here, which are starting with this greater than sign, of course, and our file is sequences.fasta. And then we do not want to see the hypothetical, so we will do grep, and then we do -v to invert our search, and then we will type hypothetical. So if I hit enter, let's see. So now we are able to see the line numbers, we are able to see the sequences that do not have the hypothetical word in it. So that's all about using Grep for this FASTA file, you can do a lot of other things with it, and you can give it a try and you can check it on your own. So now let's take a look how you can manipulate and how you can view the VCF file. So I will clear up this space, and then I will take a look at another file which is known as variance.vcf. I hope you already know what is a VCF file. If not, you can take a look at my website in the series, in the blog post where we download the data. So I explain what is a VCF file. You can also check out the video. So if I hit enter, you can see that this VCF file starts with this double hash, and then the line which has the header starts with a single hash, and then we have the header names, column names, and then we have the values over here. So initially we will have this chromosome 1, 2, 3, and then we have the chromosome, then we have the position in the genome, then we have the ID, we have the reference, we have alt, we have quality, filter, and info. Okay, now we can use our grep. So let's use grep, and we just want to see only those variants which have this pass flag. So we have given our pattern that we want to match, and then we will give the file name. And now you can see that we are only able to see the variants which are having the pass flag. And let's say that if you want to see the variants which are from chromosome 2, so we can do that starting pattern search, and we can write chr2 over here. And if I hit enter, I'm able to see only those variants which are in chromosome 2. So this can be really helpful. You can also take a look at the chromosome X. Just type X over here, and then you're able to see the chromosome X. Let me clear up some space over here. And then what if you want to see for some specific variant with some specific ID? So you can do grep, and then you can give it the ID, which is going to be RS234567, 234567, just to be sure that this is a simulated VCF file. It's not a real file, it's just for practice purpose. So if I hit enter, we should be able to see all the variants that have this ID. And you can see that in this file, we have this one variant which has this ID. And now if you want to see low quality variants, you can type low qual. And if you hit enter, you are able to see the low quality variants. And what if you want to count the number of low quality variants in it? So you will type -c over here, and then you are able to see that there are 2 low quality variants. Let's combine and do something cool with our grep command in the VCF file. So we want to see all high quality pass variants on autosomes, and we want to exclude the sex chromosomes. Let me clear up some space, and we will use this grep. Then we will invert our search, and we will ignore the line starting with hash, and we are taking a look at variants. This is gonna give us all the lines which are which are not starting with the hash. So this is only gonna give us the variant lines. So now we will use the pipe, and then we will grep for pass, so that we get all the variants which have the pass flag. Then we will grep again with inversion flag, and now we will skip our X chromosome X. Okay, so we have skipped our X chromosome, and then we also have to skip our Y chromosome. grep -v, and then chr_y. And if we hit enter now, we should be able to see all the variants which have this pass filter and are only autosomal and are not on the sex chromosomes. So now you can do a lot of other cool things with this grep tool. You can direct the output to a new file. You can do multiple kinds of filtering to get your desired results. What you can do is, if you want to count the total number of sequences, you can do this cat, and now you have the complete file. Then you can pass this grep um to look for all the starting of the variants, and then you can do wc minus L. Now you are able to see how many sequences are there in this file, and we can see that we have 8 sequences. So that's all for this video. I hope you have enjoyed this and you have learned something new. In the next video, we are going to be talking about another small tool in command line, which is unique and history. Thank you so much for watching. If you have some questions or comments, feel free to leave them down below. Don't forget to join our community and to check the website for my blog post. And I will see you around in the next video.